All right, let's take a look at example number 2. This is still on page 385, and we're going to take a look at these examples. You'll notice that the denominators here still are numbers, even though now we have variables in the numerator. So really nothing is changing here. The method will be the same, and we don't have to worry about our non-permissible values because there are no variables in the denominator. So if I start with this question here, if I want to get a common denominator, I'm going to do my long method. So 2 times 2, 5 is just a 5, and then 10 is 5 times 2. Let's get common denominators, common factors between them. 5, 2, and then this 2. I'm really just doing this to kind of re-emphasize the method we're going to use later, so you get comfortable with it. But if you already know that the common denominator in this particular question is going to be 20, you can just go ahead and start with this 20. You don't have to do this. This is just optional as a teaching moment. So what do we need to multiply for to become 20? It would be with a 5. I'm going to start using dots so we don't get confused between our x's and variables. 5 needs to be multiplied with a 4. And then 10 needs to be multiplied by a 2. So hope it makes sense if I just write that as 3x times the 5 plus x times the 4 minus 7x times 2. So that's what really we're doing, okay? And then when we multiply, we're going to be careful with our signs. So this becomes 15x plus 4x minus 14x, okay? And by writing this way, we make sure that if there are any signs inside, if it's a binomial, we distribute it. Once everything is written, we will make sure that we will combine them. In this case, all of this ends up becoming what? 5x over 20, and remember we always reduce, so that's just x over 4. Or if you want to write it as 1x over 4, or if you want to write it 1/4 x, they all mean the same thing. Okay, so any way that this is, you write that answer, they all represent the same idea. And once again, we don't need to do any non-permissible values because we don't have any variables in the denominator. The next example that I want to do is this one here. And once again, in order to find the common denominator, I know it is 24, but just to kind of show you, when we do this, we'll notice that there are no common factors, so it's really just 2 times 3, which is 24. So I'm going to write them as a common denominator 24. This entire numerator is going to get multiplied by a 3. So 3 times 8y minus 3. Always put your brackets around anywhere you see anything more than a monomial, because it means that whatever you're going to multiply has to get distributed. So putting those brackets right away kind of ensures that we don't miss that. In the second one here, this one is an 8, and in order to become a 24, this one needs to be multiplied by 8. So the 3 needs to be multiplied by 8. So this is minus 8 times 2y plus 1. Now, we've written down what they need to be multiplied. The next thing is to actually multiply it out. So just like I did over here, then I wrote them out what the multiplication is. Because we have a binomial, we're going to distribute this in. So this will become 24y minus 9. And here, make sure you take your negative with you. Negative 16y minus 8. Okay, all over 24. Now we can combine like terms. So what we have here is 24 minus 16 is 8y. So you're dealing with these two. And then negative 9 and negative 8 become negative 17 over 24. Now, next thing we want to do is we want to reduce it. So here I'm going to talk about some common mistakes students make. When we're trying to reduce something here, I find things sometimes students want to reduce the 8 and the 24 So they're taking part of my expression, just part of it, and trying to reduce it. Please don't do that. If you want to reduce something, everything in the top needs to be multiplied and reduced by this number. So if you want to reduce everything by an 8, then this term and this term should be reduced by the same along with it. You can't just pick one part of your binomial expression and do this. That would be wrong. Okay? So as we sit right now, 8y and 17, they both don't have anything in common that will reduce 24. So that's my final answer. Okay? Remember, this is a number. It's almost like if somebody had a number 7 over 8 and they're trying to reduce it, and they say, oh, well, I'm going to write 7 as 2 plus 5, and then I'm going to reduce that because that's I can. You can't do that because we know 7 and 8 cannot be reduced. You can't, on your own choice, split it up in a way that it will reduce. Mathematically, that doesn't make sense. So same way, this doesn't make sense. So that means this over here is your final answer, okay?